Okay, so for this lesson, we're going to focus on, well, actually, we've already done the lesson on the mole map overview, and now we're going to look at the second lesson, which is how to calculate molar mass. Calculating molar mass is super easy. It only gets hard when there are parentheses, and even then, if you understand how parentheses work, it's really not too hard. To make things simple in terms of these lessons, I'm going to try to use the same chemical each time so that we don't have to go through the process each time of calculating the molar mass, but it is expected that you would do that with any problem. So let's go ahead and get started on molar mass. So let's say I asked you to find, well, first let's title this. And if you are working in your notebook, I would do this on a separate sheet of paper until I can tell you for sure what page this needs to go on. I do expect that these notes will be in your notebook. So we're looking at the molar mass conversion, and that was path A on our mole map. So we're looking at how do we calculate this green thing. So let's say that I asked you to find the molar mass of lead for carbonate. And I'm purposely making this a little bit more of a challenging one, okay? So just to kind of do a little bit of a recap, lead, the symbol for lead is Pb. The Roman numeral 4, since it is one of those transition metals that's located in this particular section of the periodic table, lead is actually located right here, number 82. So since it's here on the periodic table, we give it a Roman numeral because its charge can change. Things in the first and second column, and this column, this column, this column, this column, this column tend to stay the same. Aluminum is always 3, zinc is always 2, silver is always 1, cadmium also 2. So we have 3, 2, and 1. Everything else in this middle section can change and will need a Roman numeral. If that is still confusing for you, make sure you come see me once I come back, or Miss Friedman, to learn that naming system. So we know that lead has a charge of 4. And we know that carbonate is CO3 2 minus. We know that because we have memorized our polyatomic ions. So we put that together. All compounds have a charge of 0, which means I'm going to need 2 of these in order to add together and get a 0 charge. So my final formula is going to be Pb parentheses CO3 with a 2 on the outside. Just to clarify as to why we need parentheses, we need people to know that there is 1 carbon and 3 oxygens in carbonate, and that there are 2 of them. If we put it with no parentheses, it looks like there's 32 oxygens. It's just very confusing, so we put it in parentheses. All right. So that is the formula of lead carbonate. Let's talk about how to find the molar mass of lead carbonate. So anytime you have to find the molar mass, your process is always the same. You're going to look at the number of each atom that you need. So this particular compound has 1 lead. It has 2 carbons. It has 6 oxygens. Just to clarify, in parentheses, it always distributes back. That's where the 6 is coming from. And just to remind you, I always put a little a little line underneath my O, so that it is clear that it is a oxygen and not a 0. So my mass of my Pb on this periodic table that I'm holding right now, which may be slightly different from yours, and I apologize, but it's what I had on hand, is 207.2. The mass of oxygen, I kind of skipped around here, was 16.0. And the mass of carbon is 12.01. And I understand that I'm using a pen. I'm an adult. You're not. You must use pencil. Using pen is not an option at all, ever. So now we need to do some quick calculations, and I have managed to do something strange with my calculator. So very quickly here, 6 times 16, just in my head, that's the same as 6 times 16 is going to be the same as 3 times 8 times 2, 48, 96. Okay, this is going to be 24.2, and this is 207.2. What I want you to do, check my math, make sure that my math is correct, and then go ahead and pause the video, check the math to make sure the math is correct, and then we'll get back together and talk about what we need to change. Okay, so my math actually turned out to be correct. When I add these all together, the total mass of this is 327.22. And then we need to put this in the right format. So if we go back to our mole map here, the very bottom, it shows us that it should be blank grams of X is equal to 1 mole of X. That's the format that molar mass is in. So molar mass is always blank grams of X is equal to 1 mole of X. So that's going to be 327.22 grams of lead 4 carbonate is equal to 1 mole of lead 4 carbonate. This is your final answer. So you want to circle it or something thereof. We are going to be referring back to this page several times. So since this is our A, if you will, I'm just going to go ahead and flag it with some green tabs, and it looks like you guys can't actually see the whole picture. Alright, so done. Now these videos are going to be a little bit longer because I have to talk through every single step that I'm doing, but just know that if you're doing this yourself, this process of adding this up should take less than 2 minutes. So if you're taking longer than 2 minutes, you want to continue to do some practice.